So, how's everybody's con been so far? Been good? Good? Good deal. My name is Bill Sempf, and I cannot see my keyboard. Oh, I can't, okay. That light is really bright. You can find me on Twitter. I hang out on Twitter. I was an IRC guy before there was a web. I'm old, like older than snot. Anybody here know Gopher script? Like the language? You do not. You've never seen Gopher in your life, you liar. Yeah, you maybe. I had an email address in the 80s. So think back and realize when you had an email address. And so I'm older than the hills. But I really like Twitter, even though apparently they're going to get bought by somebody and probably go to hell. It's a global conversation, very much like IRC, but a much low barrier to entry. So you can chat with people, and people who are searching for keywords can jump in on the conversation and do things, and I think that's really awesome. So even though Twitter's got a lot of problems and there's a lot of hate on there, it's true, and there's a bunch of stupid celebrities doing their thing. Really, I mean, I have a tremendous collection of people, both on the security and the development side that I follow. So feel free, if you use Twitter, to hook up. If you hate Twitter, reconsider, and from there. So a little bit about myself. I'm a programmer. I have been since the late 80s. I am primarily a Microsoft programmer. I was early on a Unix guy, and moved to Microsoft with Windows 95 and the Active Server Pages stack, and then went on to ASPX and .NET. I've written several books about it. You can find me if you choose to look on Wiley Rocks originally, the red and black books with the yellow lettering, and then when Wiley bought Rocks, I moved over to them. And I've been developing in that middle business space for a long time, like department level intranet sort of line of business application stuff for a long time. But what happened is I ended up becoming the security guy on the dev team for some reason. I always ended up being the guy who was in charge of in interactivity, performance, and security on the dev team. Probably because that's where the really hard problems are, and everybody hated it because you could grind on it for weeks and not get anywhere and maybe just have to give up. And I've never minded that for some weird reason. So I always ended up being that guy. Eventually, well, it wasn't eventually. So I spent some time writing Windows 8 apps in JavaScript, which was probably the worst decision of my life. And it burnt me out so bad on dev, I went to a mentor of mine, Jim Manico, and said, dude, is there anything in the security space that I can do? And he says, well, why don't you try vulnerability analysis? You'd probably be good at it. And of course, I'd done it all along. I knew how to use all the tools and stuff as a dev team member. So, but I'd never done it as a security person before, so I started doing it as a security person and was doing web analysis for a long time. And as a dev, I actually turned out to be pretty good at it because I know where all the mistakes are because I made them all like in the last week or so. So I know where the problems are going to be, and so I can go find them quite easily. Well, in the last 18 months, well, actually about 2 years ago, I guess, a company that I was doing business with asked me if I could do an analysis on an Android app. And I was like, I guess. I mean, I diddled around with Android. I know Java. And I know how the Android stack works. And I was like, well, how different is it really than like testing a Flash app? It's basically a rich client application with services in the back end, right? That's really all it is. So I said, sure, why not? So I did a ton of research and got a pretty good tool set together and wrote a pretty decent report. And the word got around and the stuff started piling in. So now I do about half mobile and have actually since, even though I haven't been an Apple user since 92, literally, I have a full Mac lab now to do iOS testing. So maybe if the DerbyCon gods are permissive, I'll come back next year and do the same talk on iOS. But this is an Android talk. So we're going to hack Android apps for fun and profit. Because there is profit to be made. Bug bounties are a thing now. These companies will pay you if you find flaws. So you guys can all see my screen, right? Is that working? Okay, good. So here's what happens in this talk. So you can decide if you want to stay or not. This is the list of stuff I'm going to talk about. We're going to get as far as we can. You'll notice there's no PowerPoint. There are no slides. I am literally going to show you my process of how I figured out how to test Android apps. A lot of this is from other people's research, but it's all gathered in one nice cohesive place. I'm going to show you you can watch the sausage basically being made. I mean, obviously this is a list of what I'm going to talk about, right? So we're going to go from there. And I have a lot of stuff up and running on my machine. And first I'd like to talk about what it is we're looking for. Okay, so this is the mobile top 10. Has anybody here ever heard of OWASP? The Open Web, oh my goodness, I love you so much. The Open Web Application Security Project, okay? So I am the .NET project manager for OWASP, and also I run the Columbus chapter, one of the three that run the Columbus chapter. So OWASP does three things. They have chapters where people get together like in a normal meetup meeting and talk about application security. We have conferences like this one. The next one is AppSec USA next month in DC. And then we also have projects. And the projects, some of them are code projects, like Z Attack Proxy, which some of you may have used, or Dependency Check, which some of you may have used. Some of them are documentation projects. The documentation projects sometimes are very rich, and sometimes are very thin, very simple. They're almost marketing tools. The OWASP Top 10 is probably the most famous of those. It is the top 10 vulnerabilities discovered over the past 3 years in web applications. And it is one of the most cited documents in all of application security. In fact, it's almost too much cited, where people will call me and ask, can you give us OWASP Top 10 training? To which I'll say, no, but I will give you application security training. And we might cover the things that are in the top 10, but the top 10 is not an application security program. So now you'll know this. That said, the mobile top 10 brings us the same thing that the main web top 10 does. It describes something for people who do not have the technical skills in an arena to really know where the problems might lie. Probably most of the people in this crowd know what can go wrong in a web application, or at least have a good idea, even if you're not an application security specialist. But mobile is different. A lot of it is black magic. So this goes back to where like the web was 10 years ago or 15 years ago when they started the top 10 years ago, I guess, 13 years ago. And they said, nobody really knows where the flaws are. We need something simple. Well, that's where we are with mobile today. No one knows where the flaws are. We need something simple. So they wrote a top 10 list, and it's really pretty good. This does cover a lot of the stuff that you see. So I'll walk through it very quickly. The number one, very interestingly, has nothing to do with the mobile application at all. It is weak server-side controls. So for those of you who don't know, an application that's loaded on an Android phone has very little business logic in it. It is calling back to services at some server that's hosted just like a web page, and it speaks back and forth using JSON or XML sometimes, which is a data configuration format. Those services are just web pages that return data instead of HTML. Okay, you test them exactly the same way. They have all the same flaws. They're susceptible to cross-site request forgery. They're susceptible to SQL injection. They're susceptible to command injection. They're susceptible to all kinds of authentication and authorization flaws, just like a website would be. So it's very interesting that really the website that's backing a mobile application is the most vulnerable part of a mobile application. And I have found in my experience that this is true. Insecure data storage is number two. This is where you do things, your developers do things like store your private keys to do authenticated communication back to the server on the device, thinking, well, we've hidden it on the device, nobody can find it. That is not the case. Just like with a PC, a human can access every byte of data on here. So you cannot hide anything on here. Unfortunately, this means the developers will have to learn how to do very sophisticated authentication like HMAC. This is not a blue team talk, so I'm not going to go over how to do that, but I'll be at BarCon, and if anybody wants to talk about it, like seriously has this problem, come find me, I'll help you. Incident transport layer protection basically means they did not put an S in their URL. That happens almost every app at least once. Unintended data leakage. This is where there is data being passed back to the application that the application doesn't actually need, and just the fact that it's on the wire is often a privacy or other risk violation. Poor authorization and authentication is M5. That is exactly what it sounds like. It's an application where they're not appropriately checking for username and password. One of the most common ones I find is where they aren't checking for username and password. You just press submit or cancel and you get into the application. Broken cryptography is M6. This is where people are too lazy to download something that works on Android to do their hashing or their cryptography, and they write their own stack and it's broken, which happens almost every time that somebody tries to write their own. Client-side injection, exactly what it sounds, where we can perhaps save something onto the database that then would show in somebody else's machine and cause some kind of cross-site attack. Security decisions via untrusted inputs, where you're taking things like the host header and stuff like that and making decisions as to whether or not this is actually the app you think it is. Improper session handling, once again, exactly what it sounds like, not actually using the token properly. The token isn't random enough. You're not changing the session token on login, the session fixation, those kinds of things. And lack of binary protections. This relates directly to there's nothing in place to prevent me from disassembling the app and figure out how it works. This is true of almost every application out there. So these are the things that we look for. That's super easy, right? Actually, if we'd been sitting around a table having a beer, you all probably could have come up with these 10 on your own without me even prompting you, just as a groupthink exercise. The problem is finding them, because it's kind of like literally a black box. I mean, it's a flat piece of black glass. How the heck are we going to do this? So let's talk about how we're going to do this. The first thing you're going to need is some kind of a test environment. Fortunately, in Android, you can virtualize a machine. This is not true of iOS. You can emulate an iOS device. You cannot simulate one. No, you can simulate one, not emulate one. It doesn't matter. You can't actually make a real iOS device on a PC or a Mac, but you can make a real Android device. So there is a tool set that I'll show you later called the Android Developers Tools that has an emulator in it. But what I recommend is this one on the screen. It's called Genymotion. Genymotion is a wrapper over top of VirtualBox, which is a well, not open source, but it's free. Or is it open source? But it's free, certainly, product. Genymotion is free to use for personal use, but it does have a license, which I own because I use it for professional work. And Genymotion is VirtualBox for Android. And you just simply can pick any one of dozens of phones, and it will generate a new VM for you. It's very simple to use. Click, do start, and here is my VM. Oops, forgot to leave it, and here we are. So we have a virtual machine. This is by far the easiest way to test applications. You can take the APK file that you were given by the client, drag it from your desktop to this desktop, and it'll install it. Done. And then you just test. It's that simple. All of the emulated ROMs are already rooted. So you have root access to, you have SU is running, you have root access into them, and you can do things like access the file system and underlying pieces. You can make the phone do as you wish. It is a fully functioning phone, and if you're lucky enough to have touchscreen, it actually makes it super easy to use with a touchscreen. Okay? In my main workstation at home, I have a Windows 10 Dell XPS tower with 3 monitors. The center one's a TV screen, actually. The left-hand side, I'm left-handed, is actually a 28-inch touchscreen monitor that I can then have it running like this big and touch, and it's very easy to use. It makes testing very simple. You don't have to hook over something. It's much better. So this is definitely the way to do it. But this isn't enough. We can run our application that we're going to test, right? But we can't do anything. And what do you do, right? It's not really going to do anything. So let's go back and check our thing. Yes. Oh, if you're running in Windows. Oh, I should talk about Windows. If you're running in Windows, remember you will need to turn off Hyper-V to make VirtualBox work. Anybody who is taking notes, write that down. It is Hyper-V will break VirtualBox, and it's extremely difficult to Google the error message. So that's a definite gotcha. But let me talk about Windows. Probably most of the people in this room either have a diminished outlook on Windows or are frankly dismissive of it as an operating system because of its past failures. And I understand that very well. I truly do. That said, the Android development and modding scene is almost entirely consisting of 14-year-old boys. And they're all running their mom's Windows 7 laptop that she replaced this year with something new, or an iPad or something. And all of the tools that are written to do this, with almost no exceptions, run either only on Windows or better on Windows than anywhere else. And you can ask my wife, quite literally have a laptop in each platform that I use every single day. And I tried to write this talk on my Linux box because I thought it would by far be the best. And nothing worked. Nothing. Which is amazing because Android is Linux under the, well, yeah, it's Linux under the covers, but none of the tools work. Even ADB, which is the connection tool that we'll go over in a few minutes, doesn't really run great on Linux. All of these tools are designed to run on Windows. What's worse, most of them, like Genymotion, only run on the metal of Windows. So you have to have a machine with Windows installed. If you don't have one, I would advise finding one. I have done this under Windows 7, I've done it under 8, and I've done it under 10, and it works just fine in all of them. Of course, all the standard protections apply. Make sure your laptop is locked down. I mean, just because you're using it for testing doesn't mean you shouldn't take basic precautions, and Windows is like a wire sieve, I will admit. So you've got to do all the normal stuff. But if you're going to do this, having a Windows machine is highly recommended, in my opinion. So there's that. So now we have our phone, our virtual phone. The first thing we need to do is M1, right? We need to watch the traffic between the phone and the server. We're going to do that the same way as if we had a web browser. Okay, if we have a web browser, we go in, we install some proxy, and we proxy it through Burp. And that is exactly what we are going to do. In order to do that, we are going to set a new listener on port 8090. All right? That uses the all interfaces, not loopback, because we're not on our machine. I'm on a different machine. So I have to, well, I could do it with specific, but that's a pain in the butt. So I'm doing it with all interfaces. Yes, that means that if you're on the same network as me, your traffic would go through my Burp as well. That's true. You are not on the same network as me. Don't worry about it. That is what we're going to do. Then, I have my mouse. Then we're going to go into our phone. Okay? And we're going to go here. Go here. Nope, we're not. We're going to go here. And we're going to modify network. And we're going to add the proxy just like we would if we were using a web browser. That's all this is. Now, 2 caveats to this. 1, not all traffic goes through port 80 and 443. Some apps do write their own binary channels to call home. Then you get freaky. Then we got to get Wireshark out and do some nasty stuff. I'm not going to demonstrate that because, frankly, much of that is above my level of skill. I'm working on it, but I have not gotten there yet. 2, Burp will not always show you the traffic, even if it's over 80 and 443. Okay? So you sometimes will have to fiddle with Burp. So what you end up doing is you'll notice on both the target tab and proxy tab of Burp, there is a filter bar. How many people here have used Burp in the past? Okay, that's a vast majority of you. Those of you who haven't, I'm sorry. So Burp is those of you who don't know, Burp is an attack proxy. It sits between some client and some server and records traffic on ports 80 and 443. And then it provides a load of tools to allow you to do nasty things to that traffic, record the traffic and replay it with your own values and things like that. So if you look at this filter, if you are not seeing your traffic, come down and click the Show All button. Because sometimes burp gets confused when it sees data traffic, and it thinks it's binary or it thinks it's something else. Not always, but sometimes. So give that a try. If that doesn't work, fire up Wireshark, because it's probably communicating on a non-HTTP port, which is not great for you. But we're not going to worry about that right now. So once we have this configured, and we have it configured over here, we now can proceed to exercise an application and watch its traffic. All right? So we go here and we refresh Hacker News, and absolutely nothing happens. There, see? And here's the request, and here's the response from Hacker News. And now we can start to attack these requests just like we would with any other web application. But you'll notice it's coming back in JSON, right? So I would recommend, I don't have them installed, I didn't think about this till right now, but the pretty print options for burp, you can install burp plugins to do pretty print with JSON. I would recommend that so that the JSON's easier to read. If you're dealing with an XML, a SOAP app, you know, one for XML, so that you're not just looking at a block of text, those things will make it significantly easier. How are we doing here? Ooh, wow, hang on. Oh, yes. You do have to install the burp certificate. When I last gave this talk, I gave an extended demonstration of that. I no longer need to because I pinged David, the guy who does burp, and he put a page up on the burp website on how to do it, and it's super duper easy, and there's a video. So if you don't already have burp certificate on your test device, install it. It's on the burp website. Okay, so sometimes, even if it's on port 80, burp gets confused. So there's other tools you can try. Z-Attack Proxy is an OWASP product. It's one of our projects, and it's a Java app just like burp, and it's an attack proxy just like burp. The only difference is it's 100% open source and free like beer. So you can download it. You can you know, apply. Yeah, sorry about that. I've got burp running, of course. But it's exactly the same tool as burp, just things are in a different place. And sometimes it picks up on traffic, burp doesn't. So you might want to give that a try. Worst case, Fiddler. Fiddler is a developer tool, okay? It is a debugging proxy. It is designed to fix problems, whereas burp and zap are designed to cause problems. But Fiddler is exceptionally good at finding traffic. So if you proxy through to it, you might see things you wouldn't have normally seen. So one of the things you'll probably want to do at some point is set up your machine as a developer studio. It isn't actually a requirement, but it's highly recommended because there's a lot of tools that come with a developer kit that just make this a whole lot easier. The first one is Android Studio, and Android Studio isn't technically a requirement to do this work. In fact, the main benefit to having an Android Studio installed is that it has an emulator, but we're never going to use their emulator because it is not figuratively, literally 10 times slower than Genymotion. I'm sorry? It's horrible. Yes, it is horrible. But understanding how, what do you mean it doesn't exist? Well, fine. Understanding how Android applications are developed will make you a much better tester. Let's put it that way. So having App Studio installed is very good. That said, you can get by with just installing the command line tools, and they are very small. So ADB is the Android, I think Android Debugger is what it stands for. Is that it? And see, do you guys know all this? Why are you in the talk? Jeez. My dulcet tone. Oh, jeez. I'm working on it. Freaking Windows. I hate you. God. In Linux, I can just press Control+ and it just fixes. Okay. So ADB is, are there people in the room who don't know what ADB is? Please tell me there are. So ADB allows you to send commands to a connected Android device. Genymotion automatically connects the device. So it's as if it's plugged in with a USB cable. So if I run ADB, I have to do nothing else. Whoa. List, right? Oh, ADB class. ADB devices. Right. So it found my one device, right? And the best thing you can do here is you can log in. Now I'm root on that machine, just like it's a Linux box. And most of what you can do in Linux, you can now do standing here. I can look at the directories, and process-wise, in all honesty, there's a lot of things you can do. The most important thing you can do is install the app, exercise it, and then get its settings. Okay? All the stuff is saved on the device. You're going to have to look around, and I'm working on a tool that looks for changes in a lot of different places, but that's going to be a ways out. And there are very expensive tools you can use that will tell you all the changes that have occurred because of a given application. But for our purposes and for the vast majority of applications, you just need to look in data, and all of the settings for each app are in there. You can then log out, and you can do a pull. So it's ADB pull nets.web.iappari. Oh no, I'm sorry. Of course, you've got to tell the directory. And then, I forgot to save it to a file. Oh no, didn't want to. But you get the general. Oh, I deleted the pull. That's good. Oh my God. There. Well, there's nothing in it, so it wasn't very exciting. But that's okay. You get the idea. I thought there'd be something in that. Anyway, but you get the idea. You will pull down everything not everything, okay? It is possible to save things in other places, but 97% of all applications just save to the default Android locations, which is going to be in data. The developer will have had to gone to extreme lengths to save elsewhere. So tremendously much, the application, the most developed applications are going to save to that location. Then you can go and look for inappropriately saved values, like the private keys or passwords, URLs that are internal, any of the normal stuff you'd look for in a web assessment. Just Linux box, you probably know where things are better than me. You can download. So getting the APK. Okay, so there's two ways to get the APK. By far, the easiest way is to ask, if you're doing a legal assessment, which please, hopefully I don't have to say that here, ask the developer for the APK. It is by far the easiest thing to do. If you are doing an assessment for like one of your company's Android applications, go to the dev team, say, add me to Hockey. I want to be able to download the APK, and then download the APK. And there are a lot of reasons why that makes things a lot easier. That said, there is now a Chrome extension. I kid you not. When I first wrote this talk, there was a lot of different things you can use. There's literally a Chrome extension where you can go to the store in Chrome, and it will get the APK for you when you save it to your machine, on a PC or a Mac or anything on Chrome. So it's called APK Downloader, and you can probably just search Chrome for APK and find the latest one. It's super easy to get an APK file now. So that's a very easy piece of this. Okay, so we've gone over how to set up our virtual machine. We've gone over how to set up our proxy. We have gone over how to access the settings and get into the internals of the Android application from our PC. So there's a couple other things that you can do. The first one is not, oh, there it is. Okay, so, oh, good. So, LinkedIn, who was recently purchased by Microsoft, built a tool called Hark. That is an Android scanner. And it's actually kind of cool. It is on GitHub, and I recommend you download it and run it against your APK file. It's super easy to use. So it's just, ta-da, right? And we say we have an APK file, and it says provide a path, and we say we're going to do that. And then, oh, now my Linux skills are going to get pressed here. So it's, can I just do home, root, or tor, whatever? Oh, crying out loud. See, this is why we don't do live demos, people. But this would have been boring with slides, yeah? I mean, even with my screw-ups. And then it's, see, I knew I'd forget. Yeah, I know. I can't do /root? There's no, oh, I have to do /, I have to do, oh my gosh. It's exploit APKs, I was right. Jeez, after all that. I'm going to do PWD. Where's my... now I've worked everything out. Wow, this thing is not liking me now. Yeah, there it is. Okay. So, do /root here. Exploit APKs / will it let me? No, it won't let me from here. Oh, it doesn't have the. Oh wait, CD hat. All right, I thought that was going to be in there. I should have tested that before. What it will do is it will use APK tool to decompile the application, and then it will do a static analysis of the application and find all that low-hanging fruit. So if they have all the stuff that you, presuming you're not an Android developer, probably don't even know exists, like unprotected activities. So an Android application can leave an activity open so other applications can open it. And that is very dangerous because you can then build a vulnerable or a malicious application that will spin up your application and do nasty things with it. It will also find like buttons that don't have tap-through protection on them. All these things you'd have to look for manually. It's a very slick little tool, and it prints out a super nice HTML report in the end. So I highly recommend you use it, even though it's really tough to do on a really big screen like this. But it's Python. It probably would run in Windows. I just don't usually run Python apps in Windows, so I have it running on my Kali instance. Definitely something you should look at. But even better is, oh no, I'm sorry. It says Linux only here in my notes. So apparently it does only run in Linux for some reason. I don't know why. So that's one of the few, right, that is run on Linux. So we can also use a wonderful modders tool called Virtuous 10. This is another app that's so good I paid for it. It is a tool that is designed to allow people to skin applications for platforms where that's allowed, like Cyanogen. And it's literally, I mean, the guys that wrote it initially in Sweden were high school kids, and so it's a Windows app. It obviously has the .NET look about it, but it is extraordinarily powerful. It will allow us to go in and modify the Smalley code, which is like the runtime pieces of this, modify and then recompile the app and reinstall it. So if you have an application where potentially a user could do horizontal privilege escalation by modifying the application to use somebody else's data, this is the tool that the attacker would use to do it. And what's more, this is the tool you can use to find flaws in the underlying Smalley code. And there are a lot of guides out there to help you do that, not least of which being the OWASP Android pen testing cheat sheet, which is out there somewhere. I should have pulled that up there too, but it's super easy to find. You can just search for it, and I'm sure if you just search for OWASP Android, it'll be one of the top couple of results. So we can go in and look at this Smalley code. This is .NET applications compile down to IL first before they go into DLLs, and then you can use ILDASM to look at the IL code. That's what Smalley is. Okay, it is interpreted language code. You can go in and look at this underlying code for potential flaws. Like, for instance, if you want to know how they're calling the services, what kind of authentication method they're using. You can see it in the URLs, but if you want to see how they're constructing the URLs, and if they're getting a value from somewhere else on the device that maybe would be of use to you as an attacker, then you can find it using Virtuous 10. It's an extraordinarily powerful tool for the pen tester. However, I warn you, it is incredibly fragile. And in fact, the first time I gave the talk, it didn't work. And I had to just describe it, like very similar to Quark this time. I had some difficulties with it. And so I had to just describe it. I'm very glad that I got it worked out. I literally got a Java update the night before, and it completely broke the application, even though it's written in .NET, because the Android apps are Java. APK tool requires a certain Java framework to run. So there are tons of settings you have to get extremely familiar. Whoa, those do not fit in this monitor, never mind. Very familiar with as far as your APK version, and you have to make sure that like your framework is tied into the VM the app is running on. It's super picky. Fortunately, there's extraordinarily good documentation. So if you're serious about this, getting good with this tool will make your life a lot easier. So you want to look at the Smalley for the underlying source code. You want to look at the manifest for flaws in there as well. So the manifest is the config file for an application. And what do developers like to put in config files? Everything, especially if they're web developers. They'll primarily like to think of the config file as something that a user can't get access to. Well, obviously that's not the case here, right? So that is something that we want to look at. There's all kinds of, the original certs are in here. You can check and see what certs are loaded into it. You can look for vulnerable libraries, right, which there are a ton of for Android, by looking through the lib folder. Very, very powerful tool. Okay. Oh, so I'm not going to actually pull up the spreadsheet. I should have internet access, right? No, yeah, right. Android. So literally, it just this is it, folks. Here's your test plan. It's right there on the OWASP webpage. Frankly, like all your other test plans, if you take a minute to look, okay, the test guide is out there, ASVS is out there, the cheat sheets are out there. Don't tell me you don't know how to test for things. Once you have the tool set, which is what I'm giving you here, the test plan is right there. Copy this stuff over to a spreadsheet, make a duplicate of it for your test, Check each one. If you don't know how to do it, look it up. If you still don't know how to do it, send me a tweet. I'll help you. So there's your test plan. It's as simple as that. There are a lot of other guidelines out there for test plans, but a ton of it is just, use your head. Use your head, think through what it is you're looking for, and go and look for it. So that's basically my core process. But sometimes you have to run on the metal. So when you do that, you end up setting up a device level test environment. And that is what I have here. This is my test physical phone. Where is this useful? This is useful if you are doing anything device specific with the application. So if you're using the app uses the camera, though admittedly Genymotion does that pretty well. The app uses Bluetooth, the app uses GPS, anything of that nature, then but I'm not done. Gosh, hecking darn it. Then you'd be able to go and do things. Now we're going to try this and see how this works. Yeah, I know it was interrupted. That's fine. Now see, I'm making people leave. You scared them all off. So this is a 1+1. Okay, it's a mobile phone manufacturer out of China that makes it makes $700 phones for $300. And the 1+1 has a benefit of being one of the only 7 devices that will run Kali NetHunter. So Kali NetHunter is a pen test suite for Android. Now, it is not actually for testing Android apps. It's for doing regular pen testing. There are network tools on here and all kinds of little stuff. Wi-Fi tests and, oops, that's a client. I shouldn't have that on there. Just ignore that piece, okay? There is, come on, boot. All right, fine. All kinds of great tools to help you test a wireless network using a mobile device. Super awesome. But it also has the benefit of being well hardened and rooted, and it will work really well for application testing as well as for your regular pen testing needs. So I strongly recommend you track down one of the phones that NetHunter runs on and use that for your regular testing, regular application testing situation. Yeah, there's NetHunter. Yeah, so here's NetHunter. There's all kinds of cool tools in here. You can see VNC Manager, Mac Changer, Duck Hunter is on here, Nmap, all these various intelligence. These are all pen test tools. But we can also do exactly the same thing we did before, right? Where we go in and add in that proxy so that we can watch the traffic from here through Burp Suite. So there's only Android pushes to this device. That's the only thing I've done with it. I mean, I could go run Chrome or something, but you guys know it's connected. So once again, separate device running through Burp works great. Let's see what else I was supposed to say about this. So yeah, if you don't know how to root an Android phone, look it up. It's easy. Other than that, this works exactly like using the VM. It's exactly the same detail. So that's about it. Good. There's one thing I want to talk about. So I'm working on a tool. So anybody familiar with retire.js? Yes, it is a library that is being maintained by the community of known vulnerable JavaScript libraries, which if any of you are doing any vulnerability assessment, you know that JavaScript libraries are a big deal these days. Most applications use some applications use nothing but. It is absolutely essential to be running that as a Burp plugin if you're doing web assessments. There's no way you're going to remember that some obscure toolkit is vulnerable, and looking up each one takes forever. So please run it if you're doing web assessments. But there isn't anything for Android assessments, so I'm building one And it uses the same pattern as retire.js. I call it retire.apk. I've got the repository set up in the same configuration. Obviously, I don't have much in here now. I just got started on this a couple weeks ago. So if anyone is interested in it does this, so this isn't for everyone necessarily. If you're involved in the Android security scene and you know the vulnerable libraries and you would like to participate, or if you want to get into it, then this is a great way to kick in. I haven't yet actually written my core code yet. I figured out like an Android APK file is just a zip file. You can actually, if you want to do super basic analysis, you can change it to .zip and just open it in 7D if you want. And then we're going to do regex and pick up those regex commands and run them from there. So I just got started on this. So it doesn't do anything yet. It's not ready for anything. It doesn't actually work at all, but it will soon. And I think that'll be a good addition to the scanning tools that are out in place. So that pretty much covers it. I think he's going to go give me a hand in just a minute here. So, oh, really? That's it? So I will take any questions anyone has, but frankly, I'll also be hanging around the con all evening and tomorrow I'll be here all day. My wife, Gabrielle, is in the back. She's the pretty blonde. Yeah, very good. Yeah, that's good. And she's really easy to find because she's a pretty blonde and not a dumpy white guy like most of the rest of us are. So if you see her, I'll be nearby. But I'll take any questions you've got right now, too. Go.
Strategies for testing apps that for access and denying, actually working.
Sure. So the question is strategies for apps that won't install on a rooted device. I hate to be this way, but Google it. There are a lot of tools out there that hide that from you. No, it works just fine. Hey, if you're leaving, hush up so that the people who want to ask questions can. Question? Are we good? Okay. Question over here? Decompiling all the way back to Java? Virtuous 10 will do that. There's the standard Java, hell is it? The standard tool will roll it back. I just don't have it configured because I don't care. But yeah, it's built right into the APK tool. So APK tool is the underlying technology for all of this, right? For all that decompiling. And it's actively maintained on GitHub, and you can go there and find things for it. And there are settings for APK tool that'll roll it all the way back to the Java if you want. And Virtuous 10 will handle those settings. Yes.
One of the things that's been getting some press in the privacy space around applications is applications asking for access to information they don't need.
Absolutely.
Or going ahead and taking access to information that they didn't say they were going to. In terms of some of the analysis that you're doing, are there things in there about looking at what getting access to on the device?
Absolutely.
Whether that's consistent with what they said they're doing and whether you really need to put application to work.
Yeah, that's absolutely, and unfortunately, there's no good automated way to do that. But what you can definitely do is review the manifest. That's really where it's all at. All of the permissions required are in the manifests, and you can analyze them and balance them against what has been asked for, and make a decision for whether or not they're asking for something they don't need. Now, with Android 4 and up, they can't use something they haven't explicitly asked the user for by rule. There's no way around that. Even on a rooted machine, there's no way around it. You have to have it in the manifest to use it. If you don't ask for write external storage, your app simply does not see the SD card. It's just not there. So it's very solid. But that doesn't mean that users won't look because users won't look. They just say okay. They want to install the app, they just say okay. So if you're reviewing apps for your own company, going through and looking at that and calling in the dev and saying, do you actually need the microphone? Because if not, I would like that to not be in your manifest. That's a very reasonable thing to do. Yes?
How far does it permission out of the manifest until the app never knows they exist? So you'll have that version.
So the question was, how hard is it to cut an activity out of the manifest, or no, a permission out of the manifest? So do you mean from the developer's perspective, or do you mean afterwards? You know, I've never tried that. It should technically be possible using Virtuous 10. I'll have to try it, and if you use Twitter, find me on Twitter or find me any one of the 100. I'm super easy to find, and remind me, and I'll try it and let you know. Probably a bit long to do that. Oh, okay, I'm done. I'll be at BarCon. I'll be around. I'm easy to find. It's super easy to find me on Twitter. Look me up. Love to talk Android. Oh, thank you.